Welcome to a technical mathematics and mathematics video brought to you by Simplifying School. In this video, we will look at exponent laws or laws of indices. Now, before we start, if you are looking for a list of them, like a formula sheet, you can find this on our website www.simplifyingschool.co.za. Go to the free resources tab and look under either mathematics or technical mathematics. It will be under both, where you could find a formula sheet of these exponent laws. One of them would be in the form of a business card size and the other one would be bigger. In this video, I'm not just going to tell you what the exponent laws are. I mean, you could go and download the formula sheet and read it for yourself. But I'm going to tell you the reason why the one side of the equation or one side of the law is equal to the other side of the law. And this is something that not many teachers explain at school, and there are various reasons for that. That could be because there are time constraints. It could be because it's just not part of the syllabus that you have to prove it. Let's start with the very first one. This is the one most people learn as their first one. So we've got x to the power of a times x to the power of b is equal to x to the power of a plus b. Now, I'm going to show you these things with examples. So I'm going to take 2 to the power of 2 times 2 to the power of 3. We know that we can write it as 2 times 2 and 2 times 2 times 2. We know that the 2 times 2 is equal to 4 and the 2 times 2 times 2 is equal to 8. 4 times 8 is equal to 32. Now, if we had to write 32 as a prime number, some exponent, or we could say product of prime numbers, we can write it as 2 to the power of 5. And we know that 5 is equal to 2 plus 3. And the reason why I'm saying 2 plus 3, not 1 plus 4, is because the original powers that we're working with are 2 and 3. So I'm keeping it in terms of those numbers. So we see now that we've gone from something that was on the left-hand side, 2 to the power of 2 times 2 to the power of 3 in the form x to the a and x to the b, to something that is in the form x to the power of a plus b, which in this case would be 2 to the power of 2 plus 3. Next up, we've got a division one. So it's very much the same, very similar, but in this case, instead of multiplication, we've got division. Now, let's start again with 2 to the power of 3 and 2 to the power of 2. These are easy numbers to work with. They're prime numbers to work with. They're very small prime numbers to work with, so it's making life much easier to work with them. You could use other numbers as well. So we've got 2 to the power of 3 over 2 to the power of 2, which we could write as 8 over 4, and we know that it's equal to 2. So that's basically just so that we know what the answer would be. Going back to the 2 to the power of 3 over 2 to the power of 2, we could write that as 2 times 2 times 2 over 2 times 2. And we can go and cross out, cancel out common factors at the top and at the bottom. So we've got a 2 and 2 can cancel out, and another 2 and 2 can cancel out. So we are left with 2 to the power of 1, which in this case would be left at the top. But because we don't have any numbers at the bottom anymore, we don't have to write it as a fraction, we could just write it as 2 to the power of 1. We know, using the original exponents that we worked with, how we can get to 1 is by saying 3 minus 2. So we see that we subtract the bottom one from the top one. Next up, we've got a very interesting one, which is x to the power of 0 is equal to 1. So in other words, anything to the power of 0 is equal to 1. Now, the example I'm going to use here is not a prime number, but we're going to write something once again that we can turn into prime numbers. So we're going to work with a very small number 4. 4 over 4, which we know is equal to 1. Now, 4 I can write as 2 to the power of 2. So I'm going to do it both at the top and the bottom. And then I'm going to use the law that I've just worked with before this one. And we're going to write this 2 to the power of 2 minus 2, which will give you 2 to the power of 0. And we know all of that is still equal to 1. So this shows us that anything to the power of 0 is equal to 1. You could use other numbers also, but the trick is you will use the same number at the top and the same number at the bottom once you start with your fraction there in the beginning. The next one we're going to look at, I think this is number 4 now, is x to the minus a is equal to 1 over x to the a. Now here, I'm going to use once again the simplest one, 2 to the power of minus 2. We know whether we talk about minus 2 or 0 minus 2 doesn't change anything to the value that we're working with. So we're going to say we're actually working with 2 to the power of 0 minus 2. So we could go, and this time around we can go and work backwards. Use the second law that we've looked at backwards. So we can say from that 2 to the power of 0 minus 2, we can put it in the fraction form, which is 2 to the power of 0 over 2 to the power of 2. Now we know from the law that we've just looked at that anything to the power of 0 is 1. So here we've got 1 over 2 squared. That's why we could say that x to the power of minus a is equal to 1 over x to the a. The next law that we have is x to the power of a all to the power of b is equal to x to the power of a times b. Now here, I'm using x to the power of 2 and I'm raising that to the power of 3. So basically what I'm doing is I'm taking the x squared and I'm writing it 3 times, multiplying them by each other. And once we've got that, we can actually use the first law that we looked at. So we're going to add the exponents because it's multiplication and we've got the same base everywhere. So we've got x to the power of 6. Now we can write that power of 6 once again in terms of the original exponent that we worked with. So we could say that it's x to the power of 2 times 3 and that would give me the 6. So that's how we can get from the one side to the other side. We can actually kind of like prove it with these numbers. Now the next one that we're looking at is x times y all to the power of a. And the law says that it should be equal to x to the power of a times y to the power of a. Let's see if we can prove that with numbers. So let's say we've got 2 times 3 to the power of 2. Squaring something means we can write it twice, just like we did with the previous one where we raised it to the power of 3 if we wrote it 3 times. Here we can actually write it 2 times. So we've got 2 times 3 times 2 times 3. Now we've got bases that are the same and it's multiplication, so we can add. So we've got a 2 from the first bracket and a 2 from the second bracket. So we've got 2 to the power of 1 plus 1 and we've got a 3 from the first bracket and a 3 from the second bracket. So we've got 3 to the power of 1 plus 1. Now if I simplify those powers, I get 2 to the power of 2 times 3 to the power of 2. And that's how we can go from the left hand side of the equation to the right hand side of the equation from this law. Next up we've got a fraction. So we've got x over y all to the power of a is equal to x to the power of a over y to the power of a. Now this one I'm going to use 5 over 3, the 5 over 3 to the power of 2. Once again I'm going to write that squared bracket as, basically I'm going to write 5 over 3 times 5 over 3. Now it's top times top, bottom times bottom, like we always multiply fractions. So we've got 5 times 5 at the top and 3 times 3 at the bottom. 5 times 5, it's the same base multiplied, so I'm going to add the invisible ones that we have there as exponents. So it's going to be 5 to the power of 1 plus 1, which is 5 to the power of 2 at the top. And at the bottom we've got 3 to the power of 1 plus 1, which is 3 to the power of 2 at the bottom. And that is how we can go from the left hand side to the right hand side and actually prove that this law works, but in terms of numbers now. The next one we've got is a little bit more complicated, but it's not impossible. So we've got x to the power of a fraction, x to the power of 1 over some number, 1 over a, is equal to the 8th root of x. So in this case I'm going to take 16 to the power of a half. The reason why I'm taking 16 to the power of half is because I can actually go and write 16 as 2 to the power of 4. Now 2 to the power of 4 raised to the power of a half would actually be, like we said earlier, we can actually multiply the exponents. So we've got 2 to the power of 4 times a half. Now if I multiply that, I get 2 to the power of 4 over 2, which is 2 to the power of 2, which we know is equal to 4. Right, so we know our answer is equal to 4, but we also know that 4 is the square root of 16. And the reason why I'm saying square root is because we are working with originally with a power that has a 2 in the base. So I'm not going to take the 4th root now, which one can also take with 16. But I'm going to take the square root because our original power had a 2 at the bottom. And here we can see that the bottom of the original power is the one that is the root. So if it was 1 over 3, let's say for 27 we got the 3 to the power of 3. So 27 to the power of 3rd would then be the 3rd root of 27. This is getting more and more roots. But don't worry. Here we're going to use the 5th root of 2 over 3. So I'm going to write it as a fraction, the root as a fraction. So I'm going to write as 2 over 3 to the power of the 5th. Now we know from the previous rules that we can split it. The power can go to the top and the power can go to the bottom. And then, once the power goes to the top and the bottom, we are going to basically work backwards again. So we're going to take that powers and turn it into roots. Let's go through this. So we've got the 5th root of 2 over 3. We're changing it into 3 over 2 to the power of the 5th. We split it into 2 to the power of the 5th over 3 to the power of the 5th. And then we are going to take it as the 5th root of 2 over the 5th root of 3. The second last one that we're going to look at is the 8th root of xy is equal to the 8th root of x times the 8th root of y. In this case, I'm going to take the 5th root of 2 times 3. Once again, I'm going to change it from the root form into a power of a fraction. So it's going to become 2 times 3 to the power of the 5th. I'm going to take that 5th and I'm going to distribute it into each of the bases there. That's going to become 2 to the power of a fifth times 3 to the power of a fifth. I'm taking this now back to my root form, and I get the fifth root of 2 times the fifth root of 3. And then the last one, which has got even more roots. We've got the 8th root of the bth root of x. That is equal to the bth root of the 8th root of x, and that's equal to the abth root of x. Now, I'm just going to show you how to go from the very first of this to the very last, but you would be able to go from the middle one also to the very last one, and therefore they would be the same. So let's start with the fifth root of the third root of 2. So I'm going to take the inner root. I'm first going to take as a power, so root. I'm going to change into a power, a fraction power, so I've got the fifth root of 2 to the power of the third. Now I'm doing the same with the outer root, so it's going the 2 to the power of the third, all to the power of the fifth. And we know from some of our previous laws that we can multiply the exponents. So we've got 2 to the power of the third times the fifth. That would give me 2 to the power of the 15th. And then I could take that into root form again, so it becomes the 15th root of 2. Now that you know a little bit more about why the exponent laws or the laws of indices are like they are, why not share this video with everyone in your class and subscribe to this channel for more videos about topics you are studying.